All right, I think we're almost to the end of this trade show. Second last demo of the day here. Lots of relief on our side of things. I'm sure a number of you are looking forward to going and propping your feet up somewhere and not walking the concrete for the next 8 or 9 hours. So in this particular presentation, we're going to be looking at the Maya Entertainment Creation Suite, which is going to be focusing largely on Maya, Mudbox, and Motion Builder. We're also going to be doing a bit of live motion capture with our partners from Xsense, who you can see here. We've got Emerald in the suit, who's going to be moving around for us and showing how data can be moved into Motion Builder in Maya. For those of you who haven't been around this week, you should be very pleased to know that originally the plan was that I was supposed to be in the suit for the entire time. Didn't look so good, didn't work out that well. Thankfully, Emerald volunteered graciously to take on the role, saving me from lots of embarrassment, pain, and it was just ugly. So at this point, what I'm going to do is I'm going to hand over to Daryl, who's going to start us off inside of Maya, and take it away, Daryl.
Thanks a lot, Sean. So we're going to spend about the next 45 minutes to maybe close to an hour talking about some of the things that we can do with the Maya Entertainment Creation Suite. Obviously, it's a set of tools based around Maya as the hub. We're going to be using Maya Mudbox to do some sculpting on this girl's dress, as well as Motion Builder to add some performance animation into our scene here. So when working in the Entertainment Creation Suite, the thing that's really nice about it is the ability to get data easily between these different applications that come in the suite using single-click operation. So we'll see a bit of that. And we'll try to highlight some of the improvements that have been made to the 2013 release, kind of showing you some of the workflow enhancements that we've added into the applications. So obviously what we've got here is a girl in an environment. This is actually an image-based lighting probe that came from hdrlabs.com. Those guys were nice enough to share that with us. And we've got some geometry that we want to begin further refining. And to do that, we're going to jump into Mudbox. So this is, again, a very fast and easy operation to do inside of the Entertainment Creation Suite. You just select the object that you want to send to any application. Notice we now have the ability to send it to Max. We actually sell the Ultimate Suite, which comes with Max, Maya, Softimage, Motion Builder, Mudbox, and Sketchbook Designer. So if you do 3D, there's a good chance that one of those applications will solve your problem. So for this example, what we want to do is get into Mudbox to add some further refinement to this dress, both in the form of sculpting detail and texturing detail. So we'll just send that as a new scene. It'll take just a second to pop it up. And there we go. So what we have here is we've got a piece of geometry. Notice that those hard edges came in. That's something that's been added to the 2013 release that we want to begin further refining. And when working in Mudbox and doing sculpting work, we actually are moving vertices. So if I was to get some fine detail on this object, I can't really do that at its current level of subdivision. So we're just going to jump this up a few times here to something like level 4 to add some more vertices, and we're actually moving true 3D geometry when we do these sculpting operations. It looks like I went all the way up to version 5, which is okay. That's 1 million polygons. So we'll hide the display of that. And the way the tool is set up is very easy to get into and begin working with. It's basically an artist tool. It's extremely fast and flexible. So we've got some sculpting brushes down here on the bottom. We have the ability to modify the tip or maybe a stencil that we project through or the fall off that brush on the right-hand side. And then we have a very simple layering system on the right-hand side. This allows you to use industry standard workflows like a Photoshop layering workflow to do both sculpting and painting. So for this object, the first thing we want to do is begin just sculpting some extra little wrinkles or pleats into the dress. It's always a good idea to make a new layer. This means that what we're going to, let's jump over to our sculpt layer here. We'll make a new sculpt layer. This means that any of the changes that we make to this piece of geometry are non-destructive because they're going to be done on that layer. So I could turn the layer on and off, adjust the opacity of the layer. So again, it's all about bringing productivity into your workflow. So let's grab a sculpt brush. We'll jump over to the stamp. I want to get this little kind of line there going on that guy. And we'll just start to really quickly sculpt down on this. Now notice as I draw, I'm getting a little arrow kind of giving me a guide as to where I'm going. That's actually steady stroke that I have turned on. And what steady stroke does is it actually removes some of the noise in my wrist, and it gives me sort of a dampened effect to these brushes, which is great if you're trying to draw very specific cut lines or maybe some seams on some fabric or something like that, or you're trying to trace around a character's eye with some makeup or something. That steady stroke really assists you in that process. So I'm just going to kind of crank around this really quickly. I'm not trying to be too precise with this. I can kind of come back and make edits to it at any given time. If I hold down my control key, you'll notice that I get the inverse operation. That's for both painting and sculpting. And if I hold down my shift key, what I get is I get a really nice blur function. So that'll allow me to come in here and kind of just pressure sensitively push on that really hard and sort of blur that out a little bit on the top there. So it sort of kind of fades in on that. So what we're doing now is obviously we're capturing all this detail on a very high-res mesh, and it looks pretty good. The next thing that we're going to do is we're going to quickly jump over to the paint tools. And it's worth mentioning that the user interface in the 2013 release of Mudbox has had some improvements made to it. You can now take any of these panels and begin docking them around. You can save these layouts out to predefined setups. So if you're only going to be doing texturing work, you might have a different layout than someone who was only doing sculpting work. So it's important to mention that change that's been made because it really does allow you to kind of, again, increase your productivity by filtering out the tool set that's displayed to you at a given time. Let's jump over to our paint layers and create a new paint layer. In this example, we're going to be painting on the diffuse channel. It makes the most sense. Again, this is a non-destructive workflow. It works very good with Photoshop. These layer stacks will have channel modifiers on top of them that allow me to adjust sort of the blend modes on that. So it takes just a second for that to load in. And what we want to do is we want to begin adding some base color to this. So we're going to jump to the paint tools. And for this example, what I want to do is I want to do some projection painting. So I'm going to jump to my image browse and just load up a base texture. So this was the original fabric. I sort of sampled a little region, and I tiled that out to make this larger region of that. It's actually a French O'Lily fabric. I scanned it in from one of my daughter's dresses and kind of tweaked the colors a little bit. So we'll set that as our base that we want to rub through. I can increase my brush size by holding down my B key. I could turn on my mirror. If we double click on this guy and get that back here, you can see that I can turn the mirroring on across the x-axis. That'll just kind of speed up that painting process. So again, I'm just trying to get my base color kind of rubbed onto this, and we're projecting through that to do that. So we'll just kind of flood this in really quickly here. Doesn't have to be too perfect because we're going to go ahead and start to add some other detail on top of that. So that looks pretty cool. We'll go ahead and we'll create a new paint layer. Again, I'm just painting a 2K layer. It's worth mentioning that Mudbox has the ability to do a UV-less workflow utilizing PTEX, which was developed by Disney and Sony. It's a very, very cool technology. We're not going to go into it too deep today. Or actually, I'm just going to mention it. It's worth checking out on our website. We have a lot of tutorials and a lot of online elements that you can use to go ahead and get more knowledge on this on the area, which I'm sure many of you are watching me do this demo on right now. Let's go ahead and jump back to that image browser, and we'll just grab maybe this sort of looking paisley thing, and we'll set that as our stencil. We'll go back to that 3D view. So again, I can just use hotkeys to kind of position that, move my object underneath it. We'll turn that mirroring off on that projection this time. We don't really need to do that on both sides. And I'll just sort of rub that in on this new layer. So we'll just put a few of these sort of around the base of this girl's dress here. Again, doesn't have to be too perfect because it's just a demo. This isn't going to go off and get projected out to the Super Bowl or something like that. Let's go ahead and grab our paintbrush here, and I'm going to paint in a slightly different manner this time. So with this brush, what we're going to do is we're going to jump back into the image browse. We're going to grab this, and instead of setting a projection that we want to rub through, I'm going to set this as the stamp of that brush. So by doing that, you can see it now has used this stamp image. We can jump back into that 3D view. And I can use this to just start sort of brushing on some of these. And again, notice the pressure sensitivity of that. So the harder I press, the bigger they get. If I press really light, they're going to be nice and soft and kind of move around. Now, if I wanted to have a very precise curve that I wanted to snap these onto as a guide, this has been added into 2013. So if we go into our curve tools, and I grab this create curve, if I draw on the screen here, that just lives on the screen. If I draw on the piece of geometry, it'll actually be attached to that piece of geometry. And the thing that's kind of cool about this brush is the curve tools is they will actually snap onto each other. So I get that I want to join that curve. And this gives me a really easy way of getting a stroke that will actually go all the way around my piece of geometry here, my girl's dress. And we'll just sort of finish this off by grabbing that and just sort of adding it in right there to the very end. So with that done, we can jump back to our paint tools or our sculpt tools, grab our brush. If I select this curve, the brush will actually snap to it. And I can just go ahead and really quickly say stroke on that curve, drop that guy down, and you can see that we were able to basically stamp those flowers around that dress. Now, as I previously mentioned, all of this detail that we sculpted into this has been done on a very high-level piece of geometry. So it's it could be up to 10, 15 million polygons. That's not something you want to bring back into your 3D animation package. So what we want to do is we want to capture this high-res detail in the form of a map, and we can utilize that at the rendering process to simulate the effect of this very high-res piece of geometry. It could either be a normal map or a displacement map. And this is very simple to do inside of Mudbox. It's an extraction process. So we're going to go ahead and create a new map. We're going to tell it that we want to create a new normal map, which will, again, give me an easy way of representing that high-res piece of geometry in the form of an image. Let's go ahead and just set that to subdivide. We'll tell it to be dress normal. We'll overwrite that file. That's fine. So we're going to just write out a simple 1K image for this guy. And we'll say extract. It'll go through. You can see the processing happening down here. We'll OK that, and we'll close this down. Now, as soon as I close this down, in a second there, you'll notice that it's going to get a double relief. And the reason that happened is because we now have the normal map trying to show the effect of that sculpted detail, as well as this sculpt layer that we added. So if we turn off the sculpt layer, you can see that we've now captured all that detail in the form of that normal map, which is what our 3D application expects and what our rendering engine wants to use to simulate that kind of high-res piece of geometry. So to get this information back into Maya, again, we're going to use that single-click operation. So we'll just go up to our File menu. We'll say Send to Maya, Update Textures in Current Scene. We'll send that base mesh across. And in a few seconds, through the magic of through single click, we now have all that sculpting and detailing work that we added, including the very cool normal map that Viewport 2.0, which is what we're using to display this character in this scene, has the ability to display. Viewport 2.0 has been a multi-release effort. It's a very high-performance, high-fidelity viewing technology inside of Maya, and we get kind of new versions or new tools added into Viewport 2.0 every single release. So we'll turn off the Mudbox version of the dress, and we'll get to the finished product that I spent a little more time on. What we want to do is get some more geometry in here to start pointing out a couple of the improvements that have been made to Viewport 2.0. And to do that, I'm going to use file referencing. So file referencing has been inside of Maya for a long time, but it's now manageable through the outliner window. So a lot of the things that we're trying to do in the 2013 release is increase your productivity by taking things that used to be kind of scattered across different areas of the user interface and consolidating them, bringing them up to the surface level, which is exactly what we did with file referencing. We now have the ability to preview unloaded content. So this gives me the functionality of seeing nested comps or nested references inside of each other. So in my car here, I've got the wheels actually saved out as a separate file. Go ahead and load that again using the right mouse click to manage that file reference. It'll take just a second for Viewport 2.0 to bring all this in, and the screen will pop a little bit, but once it's done, we're going to be displayed with something that looks pretty cool. So I've got this car in here, and the shading on this car doesn't look that great. It doesn't really have a reflection model happening. The specularity's kind of like a blend model. What we want to do is we want to use the ramp shader, which is traditionally something that we would have to use a software render to view to make a car paint shader, and that's now got the functionality of being able to be displayed inside of Viewport 2.0. So we'll just grab that piece of geometry that we want to begin working with, and we'll just jump over to our hypergraph and node editor view. Let's go ahead and turn off a couple things in here. We'll turn that guy off, and we'll just filter that out. Bends allow me to filter what I'm seeing, so I'm only going to see the nodes associated with this car, so I can just really quickly drag that down into my view here. So we've got this base paint for this vehicle, and like I said, I want to make this into a ramp shader. So if we just double click on that guy, load it up in the attribute editor, I can switch the type of shading algorithm we're using. And again, ramp shaders are kind of cool. So when we first turn the ramp shader on, it's going to look very similar to that blend that we had. Obviously, the base color is a little bit different, but notice the specularity and sort of the reflections on that, or the specularity on that looks just like a blend. What we want to do is we want to get to something that's a little bit more advanced. So I'm going to go ahead and grab an environment or a reflection probe here. This is just that same image-based lighting probe that was used from the background, and we're going to put that into the reflected color of this ramp shader. So the node editor gives me the ability to view active connections, compressed connections, and all connections. So if I just click this 2 times, I essentially get what used to be the connection editor. So this is another example of us trying to take a couple of different windows and streamlining the workflow to, again, increase your productivity. So all I need to do is grab my out color and pipe that into reflected color. As soon as I do that, obviously I'm going to get this kind of very chrome-looking car, which isn't exactly what we want. So let's go ahead and let's turn that into something that looks a little bit better. Let's jump down to our reflectivity and bring up the ramp for that. So what this ramp does, and as soon as I start to drag on it, you'll see the effect here. The left-hand side are when the normals are facing away from you, and the right-hand side are when the normals are facing toward you on that car. And what we're trying to do is we're trying to get really bright, highlights or sharp reflections that are very strong on the glancing angles, but very soft when you're facing the object directly head-on. So if we really kind of clamp that down, you can see the effect of that ramp shader in Viewport 2.0 in real time affecting that vehicle. So obviously if I look down the side of the car right now, you can see that we've got a ton of that environment probe showing up in the reflection. But if we spin this kind of car around here and look down the side, the reflections kind of go away. Now obviously if I wanted those reflections to get strong on the side, I can just sit here and interactively manipulate this ramp shader to get to that effect. So there's been some other improvements made to the quality of Viewport 2.0. one of the things that it does now is it has a really great ability to deal with transparency. So I've got this hair on this girl right now being displayed as it's just geometry with transparency on it. So as I spin this around, you can see all that kind of popping happening. That's an object sorting error. And we can now get around that by using an advanced depth peeling algorithm for our transparency filtering. So if we just bring up the options for Viewport 2.0 and switch the transparency algorithm to depth peeling, and we start to rotate around that head now, you can see that it doesn't have that pop anymore. So this looks very similar to what a software renderer would get as far as its ability to handle transparency through multiple layers. Like if we kind of go over here, that's kind of going through 2 different car layers and about 7 layers on the hair, and it just filters and looks exactly right. You'll also notice that as I'm working inside of here, I've got this really cool depth of field effect happening. These are the types of things that Viewport 2.0 brings to the table. It's great for doing pre-visualization or maybe doing play blasts of daily comps or something like that. Viewport 2.0 really raises the level of detail that you can represent in the scene. So the last thing that I want to talk about in Viewport 2.0 very quickly, let's go ahead and show our lights here, is the ability for it to represent area lights. So area lights are great in CG. They give you these kind of large, soft, diffuse lighting models. They let you get really long highlights or really soft lighting on objects because the size of the light actually is, or the intensity of the light and the size of the light rays actually come from that area light. So if we grab this little square back here and we start to increase it, I'll just scale it out sort of along this axis here, you'll see that it gets really long. You can see that specularity kind of showing up on the ground down here, and we get that really long highlight going down that car. So let's go ahead and just grab that car shader and we'll darken that guy up a little bit here so that we can see the specularity kind of playing on that car. So you can see that really broad, soft, diffuse highlight now coming down the tail end of that car. And obviously if we hide this light, we'll just delete that light there. You'll see that we get rid of that really soft, broad highlight. So if you're trying to get things to look really beautiful, area lights will assist you in that process. So the next thing that we want to talk about is an improvement that's been made to skinning. So when you're doing CG work, obviously you start with modeling, you go in to do some texturing work, then you have some skinning operations, and that's the process of taking joints and having those joints have a relationship to your pieces of geometry that you want those joints to pull around. And traditionally, this is where an artist could spend a lot of time. We now have a new algorithm that we can use to assist us in getting that initial bind that's very, very efficient at doing it. So there's a couple of areas that would be kind of hard for a bind system to deal with. Notice how these vertices are kind of zigzagging in between each other, and this vertice on this leg is actually closer to that joint. It used to always just work by looking at a volume, sort of am I close to that joint? Well, that joint will influence me. Now with heat map skinning, it's not just based on volume, it's actually looking at the surface and using a heat map algorithm to basically adjust whether or not that piece of geometry should be influenced by a given joint or not. And it sounds, it's a lot to say. It's really a little bit easier to demo. It's one of those things where you just say do it, and it does what everyone would expect. So we have heat map turned on. We're using dual quaternion for the weighting method. And if I just grab this girl's control, which is just a simple little control rig that we can use to start positioning her, and pull that leg out, it just does what you'd expect. The initial skin bind that the heat map comes up with it's rock solid. So let's go ahead and undo that really quickly. The next thing that we want to do is talk about HIK. So Maya has human IK built into it. This is a very sophisticated algorithm that gives the ability for an animator to establish a very complex rig and very, very quickly. It's the technology that motion builders based on. And traditionally, you'd have to use sort of a built rig, this human IK control rig. In 2013 of Maya, we now have the ability to utilize that power of that human IK algorithm, but put it onto a user-defined or custom control rig, which is exactly what we want to do here. This girl's obviously got this custom control rig that's used to position her or animate her, and we want to repurpose some existing animation onto her using the powerful retargeting tools that we have. So when working with human IK, the process is very similar between Maya and Motion Builder. There's always a step of teaching the solver about the hierarchy of your skeleton. That's the first thing you need to do. So we'll go ahead and we'll create this definition, and it's, again, a very fast process. You double-click on the bone, match it to the corresponding bone in the viewport. We have name matching turned on, so it's our mirror matching turned on. So it does both the left side and the right side at the same time. Now I'm going to use a template to accelerate this process. Maya ships with templates for HIK as well as templates for cat and biped coming from 3D Studio Max. I've got a template saved out specifically for this girl, so we'll fill that out. Notice that it fills in the spine joints automatically. With that template set up, we can now lock this off. Now this is traditionally where you'd say, build me a control rig, which is that sort of HIK black boxed rig. Now we have the ability to say, instead of just building me the default control rig, I want to teach HIK about the hierarchy of this custom control rig. So this is where I want you to push the information or the animation after the retargeting process to. So again, it's a simple process of making relationships. You select the node, you go over here, you right-click on it, and you say assign this to that marker or that effector. Notice that it mapped both translation and rotation. So it's trying to match world position and orientation, or FK and IK. And we'll talk about this a bit more when we get into the retargeting, because this really is something that you need to be aware of when you're trying to repurpose animation from dissimilar proportion characters. And I can almost guarantee you that the characters that you have or the animation you're trying to repurpose will be dissimilar in size. So these are the types of things that you're going to have to use to get around those limitations. So I'm going to again use a template to sort of accelerate this out. It's worth mentioning that everything that we do as far as drawing this UI is dynamically generated. So you position the end markers in an XML file. The FK markers or bones are drawn automatically between those. So this is something that a technical director could modify so that an artist isn't displayed with extra information they don't need. Like for my girl here, I'm not concerned about using joint rotations to position her legs. I only want to use that end IK handle on the foot to position the leg. So I could have modified this XML file to get rid of that data if I was handing it off to an animator and I didn't want to confuse them. For the demo, we're going to leave it the way it is. So with that done, we have everything set up for this character to work with HIK. We're going to go ahead and jump over to the visor to just grab some clip art and drag it in here. It's worth mentioning that all of the mocap examples that come with Maya have already gone through that characterization process. So HIK understands the hierarchy of that skeleton, which means we can utilize it as a source for our girl. So we'll just go over here and we'll say mocap source. Just like that, that retargeting happens in real time on the fly. So what happens here is the retargeter by default is trying to match joint angle, and that's very clearly obvious on these girls' joint angles versus the original data that it's getting derived from. Notice that the girl covers less distance than the character that's on the left side, the humanoid character, and that's because obviously she's got shorter limbs. So the first, the kind of action space compensation is taken care of for you automatically, and the feet just work. But you're going to run into problems when you have shorter limbs, like where the arms are. They don't really hit the ground. So this is a type of problem that HIK is specifically designed to work around. What we can do for any of these given body parts on this in the retargeter is specify whether or not we're concerned about matching forward kinematics or rotational values of those joints, sort of the joint angles, which they're matching here and here, or the world position, or the kind of shrunken down world position for my little girl, because she's again a shorter character. So if I start to increase the translation match, notice what happens is the joint angles are no longer what we're trying to worry about. We're trying to get to that end position. Maybe we'll turn on rotation match so that wrist kind of flops up and matches there, but it stops at the body part. So this is where the magic of HIK comes into play. If I start to increase this pull value, the algorithm can actually transfer the energy through the shoulder, down the spine, all the way into the hips there. So it's now basically being able to pull that object or that character all the way down to get to that true matched position. So if we scrub through our time slider, we fixed one hand, it's kind of pinned in space. The other hand's still swimming, so we'll just grab that and just crank all three of those guys up. So that looks pretty good. We've got some issues with the original data passing through the ground here. So on this retargeted girl, I'm going to use another one of the powerful features that HIK brings to the table, which is the ability to have ground plane collisions happen on fingers, toes, wrists. So we'll go into our floor contacts. We'll jump into the hand. We'll tell it to turn on the wrist contact. You can see they popped right there. I'll just give it a little more bias. And just like that, we've now gone ahead and done this retargeting operation, used the power of HIK to alleviate all these differences in scale. And to finish this off, we're just going to jump back to the control rig and bake that information onto that custom rig. So once we've done that, if we scrub through our time slider, you can see that what we have here is the exact same animation as when the retargeting was happening, but all that information lives on this girl's control rig, that custom control rig. So that's really the power of Human IK. It's the foundation technology that Motion Builder is built on. And what we're going to do now is we're actually going to do some real live motion capture data, and we're going to jump over into Motion Builder to do that. Motion Builder, again, is a tool specifically designed for dealing with stage workflows, and that's what we're going to be seeing today. 2013 has lots of great new features. Again, production tools coming from the stage, and we'll kind of look at how we can use those and think of yourself or Sean as the director. So we're going to I'll let Patrick from XNs kind of give a little overview of what his technology brings to the table. It's worth mentioning that when I send this information over to Motion Builder, what we're going to be doing is instead of doing the, let's just set my character to, it's on none there. What we're going to be doing in this example, instead of single-clicking it and saying update, send, or current scene, we have a new button called Live Connection. So we're going to run this Live Connect. Notice I get a list of the characters in my scene. We'll just make that live. And if we jump over to, let's just kind of flop that guy. Oops, let's get rid of you. Let's dock this guy over here. So we'll go to a 2-up mode. So we've got, close that one down. We've got Motion Builder. And we've got this Live Connect. So that girl that was in Motion Builder was in a slightly different pose. You can see because of that Live Connect, my Maya scene has gotten that. So Maya has a port open to Motion Builder. Motion Builder is actually driving Maya. And what we're going to be doing is we have another port opened up to the XN system that's going to be driving this character. So I'm just going to drag and drop into my scene the XN's Live Connect. So we'll get that skeleton in there. So are you live?
Yep, we're live. Could you
Did
give
you
me?
plug in your Ethernet cable? So this is all based on IP. So this is going to need an Ethernet cable in there. Hopefully it's going to pop. There we go. So we've got our connection happening. We've got our girl happening. This is just a source. Same thing as we saw inside of Maya. You can switch your source to all the possible characters. We can turn off that control rig there. So we're actually, this is really cool. We're sending motion from Motion Builder into Maya onto that custom control rig through the power of HIK. So this allows us to do motion capture and have that data captured onto custom control rigs now, which is a very, very cool new feature inside of 2013. So I'll let Patrick explain his technology, which is it's pretty amazing and very unique in the industry.
Yeah, we're basically we fit very well with Motion Builder because we also are fast, flexible, and iterative. So there's no cameras. I just want to point out a few things.
Hold it up a little. Hold your microphone a little closer to your mouth.
We're inertial-based sensor technology, so there's no cameras. It's completely self-contained. And as a result, we're real-time. So we solve onto a biomechanical model, which works very well with the human IK and allows you essentially to do what we're about to show you for real.
All right, so we're going to pop up in here into Motion Builder full screen. That Live Connect is still happening, and I want to start talking about the things that Motion Builder bring to the table that are unique. So again, this is a stage-based tool. This is the director's view into that virtual world where he's trying to capture the virtual performance. And in 2013, we've got a couple of new tools that really facilitate working on a stage. We now have the ability to take our characters inside of Story, which is a nonlinear editing environment, and record their data directly to disk. So let's go ahead and look at that. And the advantage of recording to disk is you're no longer limited by the amount of RAM that you have on your system. So let's insert a character animation track. We'll set this to be that character there. So what we're going to do is just make sure that we're set to record to disk, which we are. We're going to go ahead and bring up our record options and specify the path in which we want to have this data dumped. So we'll put it to the Autodesk folder. All the nodes for that hierarchy are going to get recorded, so we'll just hit OK on that. It's worth pointing out that when we record this data, what's happening is it's going to get named with a token system. So this naming token system is something that could be trackable through your pipeline with something like Shotgun. So again, you're going to take take after take after take. It's very fast and it's easy, and because we're no longer limited by the amount of data we can shove into RAM, you don't have to tell the director, wait, we need to save everything out, come back in 5 minutes. So you never lose your momentum on stage. So that's what we want to see here is just a couple of recorded takes into Story. So we got our record button set.
All right, so basically before we get started, I just want to kind of talk a little bit about the technology and why people are using this. What we're doing here is something that we call in the industry virtual production. It's a very common thing in the industry when you're doing, say, a very intensive CG computer graphic kind of shoot. Avatar is a good example where the entire environment is CG. Yeah, you might have a few real actors, but everything is CG. It can be very difficult for directors, producers to try and explain their vision to the 300 artists working at a studio. Like, well, actually, I want the person to be kind of like this, and I need the environment like such. They could spend weeks, maybe even months, going back and forth trying to get the vision they want. But when you use technology like this, as a director, I can now direct an actual person to do what I want them to do. And the beauty is, while she's doing her motions, I can be seeing a version of the actual environment that will be in the movie. so I know what she's reacting to. I know how she's reacting. And what's even more important is I can do multiple takes in very unusual ways. If we have 3 or 4 people up on stage, all in motion capture suits, and I'm doing like a take 4, take 5, and it's just not working, but eventually you realize, oh, look, 2 of them did it perfect. I can send them home. I can keep playing those 2 people back in the viewport, and Emerald could stay behind and continue to act out the third person's shoot in relation to the 2 CG people I sent home. And then when you're done, I could then go back in later and reframe all my camera moves as a second pass. So the director has total control of deciding what this shoot's going to look like. And at the end of the day, he can send this from Motion Builder off to the studio that's actually doing the final work, and they just have to take that as their guide. In fact, it can often be the models that they ultimately refine at the end of the day.
So it looks like we lost our sync here just for a second, so
All right.
we're waiting to recalibrate our talent, which is part of the process here. She's going to stand very, very still.
Of course, we lose it just after I use up my long monologue. That's
Yeah.
always the best way to go,
The
right?
monologue too long.
That's
a trick.
monologue was too long. There we go.
I saw that in The Incredibles. That's a nasty trick you can do to someone. You get a monologue and you just whack them in the head, and down they go.
All right.
All right, are we live? Do we have some
Move
movement?
around.
Okay, we're good. We're back.
All right, we're back.
Just
okay,
like that,
so
the magic of
Emerald, why don't you go
computers.
over to the far side there? So in this particular shoot, we are treating this large boxy object as the Porsche. It's
Porsche.
obviously
There's an A on the
Porsche.
end of that.
Sorry,
Let's
Porsche.
get it right.
The non-car person, car person. So obviously it's had a bit of a downgrade in the real world, but this is actually pretty realistic to what would happen in a motion capture environment. You often will have boxes, blue painted objects, you name it, standing in for things that are happening in the virtual world just to give the actors and actresses something to go by. So in this case, what we're going to do is Emerald's going to walk towards the car in a rather aggressive kind of way and kind of tell off the driver. Obviously not liking Daryl. Daryl apparently not getting along with our mocap talent. So when I say action, Emerald, just come to us with all the aggressiveness you can throw at it, and action.
So as she walks up with fierce attitude, clearly unhappy with me for whatever I've done to her, you can see that this take is being streamed directly to disk. So we'll go ahead and we'll stop that really quickly here. Notice that it's got that naming token system kind of adding the name, the date, the time, and the second that it was done. So this is the idea here, that we don't lose the momentum on stage. We want to do another take. She walks back to the other side. The director gives her some revisions, perhaps. Maybe not so
Yep.
angry at me this time.
Yeah, we'll be a little nicer to Daryl. Still more on the aggressive, but let's make it more of a let's get the hip swing kind of a little more into it. Try and get more womanly action into the motion.
Oh, no.
Take that phrase. I don't know.
We've lost our link one more time.
Oh, stand still. Come back over.
We need to recalibrate. We'll get it.
One of the things that we find as a challenge in this space is if any of you pick up your iPhones and Androids and check your Wi-Fi, I'm not blaming your phones. I'm just saying if you look at your Wi-Fi, 600 Wi-Fi hotspots show up in your thing. They're all transmitting Wi-Fi in this
So
space.
let's actually jump to a 3-up view really fast, guys. I'll talk about the SDI out. So this is another new feature that's been added to the 2013 release. We now have the ability to have a serial digital interface output, which means you can dump this direct to editorial with Genlock timecode. So if we bring this online, you can see that we now have a director view. Let's go ahead and just switch our camera over there to that guy, and we'll just jump to a 2-up view here. So we've got our kind of director view, and then we've got our CG driver view over here. This kind of Genlock output, again, is the view that the director would have. It could be being dumped right into an Avid for editorial work happening with that Genlocked code. And we also have some really nice new improvements made to the ability to have custom slates, heads-up display. So I'll just drag and drop one of those on here very quickly. So if I grab this HUD, what this one has is it's got some stuff already built into it. We'll add it to this camera. Oops, let's add it to all the cameras in my scene. See here, add to the scene. All right, well, the heads-up display you can see on this side over here. What the heads-up display does is it's dynamically driven. You can take any attribute that's queryable on side of this system and have it pipe into it. So things like the take, the time code. You can have image maps adjust or thrown into there. The black bars are dynamically driven. You can also have things like animated flash files coming from our Scaleform technology directly in the viewer. And that can be something like you're doing an Iron Man movie and you want to see kind of overlays of animated graphics in his heads-up display. You can actually utilize that flash technology for the director to get a sense of what's this motion capture look like, this performance animation look like, with that layer of animated flash files on top of it. So
Shall we go
we'll
and
do
grab
one
that
more
last
take.
clip?
we'll jump back into story really quickly. And we
right,
can
head on
just
over to the
record
other
anything. It
side.
doesn't matter what we record. Let's just get some more data in our
Yep.
system.
All right, so again, as we were saying, just a little more hip action, same basic aggressive kind of mode, and action. And cut.
All right, so there we go. We've got some data. We've got a bunch of stuff recorded out. So let's talk about a couple of other improvements that have been made to story. So what we have here in our timeline is we've got this animated camera, obviously, in our director view. I'm going to go ahead and drag that into my story timeline. We're going to insert a generic camera animation track, and we'll just set that to be camera 1, which is that camera that we saved out. So now that we have a couple of objects or a couple of things inside a story, we're just going to insert the take of that track. So we'll just say insert current take for that guy. So we've got this kind of scrubbability inside of here. These clips are unloaded. These are just disk-based clips.
Let's
so
go
if I want
back
to
to
begin
the two up
working
view,
on
guys.
these, what we're going to do is we're going to go ahead and we're just going to load in that clip. Once I get that clip, we'll load this one in too. Why not? Once we get these clips loaded into story, it gives me the ability to start making nonlinear editing changes to these guys. So what we've got here is we've got a new folder system that allows me to basically embed all of this stuff into a folder and begin working with them at a slightly higher level. Let's go ahead and insert another character animation track in here. So we'll just say insert. Let's get another character animation track, and we'll shove our humanoid character onto that. We'll drag this clip down to that, and we'll just display that humanoid. So now what we've got is we've got, nonlinear editing happening, multiple characters, multiple tracks. I can scrub through this and see everything that's happening in my scene, and we can begin actually moving all of this together. Actually, it looks like we need to drop that humanoid in that folder, so let's just do that quickly. Let's get you in there. Come on. Boop. There you go. So now I can move all three of those guys together. Another thing worth mentioning is our support for audio has had a little bit of work done to it for this release. We now support broadcast audio WAV files. So again, utilizing that time code information to make your shots and your pipeline just work. So if I drag and drop that onto the folder, it'll also get embedded into that. It's worth mentioning that the time code, or the WAV files now have the ability to have time stretches done to them and maintain pitch. So a couple of other things that are worth mentioning is if I wanted to make maybe an editorial change to all these clips at the same time, if I do something like a razor cut on the folder level, oops, let's do it right here. Do a razor cut at the folder level, you can see we basically got all of those guys cut back and edited back. If I start deleting these, that folder will compress down to, kind of encompass the overall range that we have. And the last thing that's worth mentioning is, again, that ability to stretch time. So as I start to stretch that out, you can see that the audio is going to play back at halftime, as well as all of those transitions and all of those camera moves. So those are a few of the improvements that have been made to the 2013 release of Motion Builder. Again, all very focused on the stage workflow. So I'd like to thank XMs for coming up here and flying out, bringing their suit.
And we'll just do one last thing just to kind of show off the suit a little bit before they step off the stage. But we're actually going to be doing a drawing during this presentation at the end of the presentation for a Quadro 4000 NVIDIA graphics card. So you all are luckily sitting in the stage at just the right time. And now, mental note, this is for Windows PCs, not for Macintosh, just in case you wanted to know. So what we're going to do is we're going to do a first pass of gathering some cards here. So I'm going to get Emerald to just go out into the audience, and anyone who has business cards, please put them in the bowl. That will be what we'll be drawing with. And I want you to notice, as this is happening, if we were in a typical motion capture studio where we have lots of cameras and everything else going on, we'd have no control over expanding our volume. And of course, just her walking amongst you would be occluding all the sensors on her suit. But we can actually see her out there now walking around, getting cards. And in fact, if we didn't have tons of Wi-Fi all around us, we could probably have her walk all the way around the booth, and you could actually continue to track her mocap all the way around the booth. It's actually really quite impressive. So you'll have a second chance right at the end of the demo. For those of you who don't quite get to the bowl the first time around, you'll have a second chance to drop a card in there.
So it's worth mentioning that while we were doing that whole demo, we were live streaming to Maya the whole time in the background. So
Exactly. Absolutely everything is constantly...
With the SDI out, getting dumped to editorial with
Yep.
timecode genlock also at the same time. So very, very powerful, flexible tool for doing this type of work.
Oh, we got a couple more cards over here on the side. There we go. So again, just really impressive technology, powerful. And now I'm going to call Emerald back because we want to get Daryl go on to his next piece.
And she
Thank you
can
very
walk
much,
through
my lady.
walls and cars. It's amazing.
Yes.
X-Men powers right there.
So again, thanks to XSense for coming out and helping us out. And we'll move on now to back into the transition to Maya, I guess.
Yes, sir. Let's do that. So some other tools that are inside of this release for Maya. Again, a lot of the features that came in the 2013 release were trying to increase productivity for people that are doing long format work or working with multiple artists. And there's a couple of really great things that have been added to Maya for sharing animation data between different files. So there's a new Atom is what it's called. So it's an animation transfer object model. That's a lot to say, but what it does is very basic. It sends animation from one object to another object through a disk-based file. And it has a really cool templating system that allows us to specify the amount of, at what level we want this data written out, how many nodes we want it written out on, so we can use that filtering both on the export and the import of the animation data. So I'll crank through this pretty quick, because I know we don't want to run into Will's time. We don't want to steal of any. I have 15 minutes. Well, then, heck, I can show this and end here. I'll do it all today. It's because I had a Red Bull, so I'll get through my demo no problem.
It gives you wings.
That's what they told me. I believed it. All right, so what we've got here is we've got this girl. She's got animation on her, and we want to export this out to a disk-based file, again, to be repurposed or handed off further down in the pipeline, or maybe it's you've got episodic work and you animated something at episode 21 and you want to use it in episode 40. You don't want to reanimate it. It's really easy to get the data out and into the next scene. So what we're going to do is we're going to go ahead and we're going to select some objects that we want to send out to Atom. And I know that I'm going to use the same selection over and over again, so I'm going to generate a template that I can reuse over and over again to kind of capture that selection. So we'll bring up the Create Atom template. We're going to give it a name of something that's a little bit more meaningful than DTO, like DTO2.
Very meaningful.
Yes, sir. We're going to turn off Create View, because we'll get to that in just a second. So with that current selection, we're going to say Apply. It's going to write out that template file. So the next thing that I want to do is I want to make a filtered version of data. I might want to be able to query the hand movement or the head movement independently of all the animation. So the first level that we just sent out was everything. Now I'm going to select just the head, and you can see that my selection of my outliner is a slightly different version. We'll say Create View, and we'll hit Apply one more time. It says Replace File. It's not really replacing the file. It should say Add Data to File. It's unfortunate that we call it Replace, because we're not overwriting the file. We're just pushing more information into the file. So we do that for the head. We'll grab the arms next here. And we'll leave that Create View on, and we'll call it Arm. Let me make sure I clicked Arm on that one. I did. So if we expand that out, you can see that it's got spine joints, the hand joints. So again, we're just grabbing the nodes that are important to get the arms animated, and we're creating a view or a filtered representation of that data in the template right there. Again, it's not replacing, it's adding data to the scene. So now that we've set that template up, we can reuse it over and over for this character. It's a one-step thing. You do it once, you're set and ready to go endless times. So now we're going to export the animation on this girl. We'll call it Walk DTP, and looks like I was typing that very quick, so we'll call this one Walk DTO2. So that's the Atom file. That's where the function curves are going to get written. Notice that we can write out set-driven keys, constraints, animation layers, static values. Very important to be able to write out static values. And we're going to use this template. We just made a new one called DTO2. And when we do that, you can see that on the export, I have the ability to filter the information. Do I want to write out only the head animation, only the arm animation? I'm going to actually write it all out into the Atom file, because same view and filtering operations are available on the import. So I'd rather have all that information included in the file. So we'll go ahead and we'll say use the time slider, range all. That looks great. We'll apply that. Oh, nothing is currently selected. I don't believe you. We're using a template. It should be fine. Let's go ahead and apply that. All right, just like that, the Atom file was written out. So let's open up a new scene. And we'll grab a version of this girl that does not have any animation on it. So we'll grab version 2. It'll look similar, but when we scrub through the time slider, you'll see that obviously there's no animation data in this file. So it takes just a second to load up. Again, that really great image-based lighting probe from HDRI Labs. We scrub through this, and there's no animation on it. So let's go to our import animation. Let's grab that import animation. Again, we're going to use the Atom file. We're going to use a template. Notice the views are loaded up there. So we have arm, head, or none. So if we go ahead and we say arm, and you can do string matching. So if you want to do simple search and replace, or if you want to do a bit more complex search and replace, say the names were slightly different on girl character versus boy character, but it was the same basic kind of layout. You could use the search and replace to kind of get around that really easily. We'll just go ahead and we'll apply that. And what we get is obviously just arm animation because we, again, use that filter or that view to do that. If we switch it over to head and we hit apply, now we're going to get the head animation kind of coming in. Let's go ahead and select a node on that and hit apply. So now we have arm animation and head animation. And then obviously if we switch this view to none, select a node and hit apply, we will get that full animation transferred over. So this is one of those tools that it's, if you're working on large format production or you're trying to repurpose information over and over again, it just saves you a ton of time, and it increases your productivity drastically. So the final thing that we're going to talk about really quickly is some improvements that have been made to dynamics inside of Maya. We're going to be looking at the new in-hair solver. So what in-hair does is it uses, it has the ability to interact bidirectionally with other in objects, which are in particles and in cloth. So that means hair can move cloth, particles can move hair, and kind of vice versa. So let's go ahead and pull up this scene file really quickly. So the workflow for this, and a lot of it's kind of very similar to using the traditional hair system inside of Maya. We just have that power of that nucleus framework underneath, that unified simulation framework underneath it. So what we're going to do is we're going to grab a piece of geometry. Actually, we'll grab a piece of geometry. It's just a simple little cube, and I'm going to use that to generate a ponytail. So we'll run the create hair command. It'll go through and create some hair. Again, it's using the in-hair solver. So if we play this back, it's going to play back very quickly, but it's not going to really interact with anything in the scene. So this is the first thing that we want to address. We want it to collide with this object. So we'll create another in object, a passive object, a passive collide object in there. We'll bring up the attribute editor because while this plays back, I want to sort of interactively modify some of the attributes on the hair here. So it obviously comes down, hits the back of the girl, and it interacts with that. That's great. The problem is that the hair doesn't really have any volume preservation happening because there's no self-collisions turned on. This is one of the things that the nucleus system is very efficient at doing, collisions. And advanced collisions, not just at vertice levels, but down the length of the curve or on the edges. So if we turn on self-collide, as soon as I do that, that hair kind of pumps out. We can look and see that, again, that self-collision happens down the whole length of the curves. And what we want to do is use some of the traditional hair tools to begin further refining this hair and sculpting it. So I've got these kind of ramp modifiers that adjust the overall size of the hair as it shoots down the shaft. And we'll just further dial this in by using a preset. So we'll just kind of crank that out. So look at the speed at which this is happening. I'm using HIK. This is that HIK control rig to update this girl's movement. So lots and lots of curves, complex self-intercollisions happening with an HIK rig moving the character underneath it all. So let's go ahead and reset that back to the start pose. The next thing we're going to talk about is the ability for all the other dynamics in constraints and in particles to interact with this in hair. So we've got the hair selected. I'm going to grab the first control vertex of all those dynamic curves, and I'm going to create a constraint, a simple transform constraint of those. We'll hide those start curves, and we'll play this back one more time. So now that hair is penned in space. I can actually use this as a styling tool to begin kind of maybe putting some twist into this hair. So I can just grab that hair, start twisting it up. Notice the self-collisions, maintaining that volume, preserving that volume. And this stuff, we just couldn't do this before with the old solver. The other thing that's worth mentioning about these constraints is there's lots of attributes that you can adjust to modify the way they behave. And one of the interesting ones is glue strength. This is a threshold, and once it gets exceeded, there's enough tension or pressure on that constraint, it'll actually break. So there goes my hair kind of falling down, and it just drops to the ground. Let's just rewind that one more time. We'll reset this, and we're going to finish off by getting a particle system in our scene. So let's go ahead and get these particles in here. If we play this back again one more time, that constraint's kind of holding it up. These particles are coming down. They're obviously interacting with that hair. They're kind of sticking to the hair. It's bidirectional. So if I move the hair, it's going to push those particles up. Notice the constraint just broke. The last thing that we're going to do is just modify some of the attributes on these particles to make them a little bit heavier. So we'll just go to a preset for those. We'll call it, I think it's Hair Waters, the one that I made. And we'll just grab this emitter and go to interactive playback one more time. So those particles have a lot of mass as they kind of wipe across that hair now. Just kind of do something like that. You can see that they're going to increase enough pressure on that constraint to break it. So this is really what the in system is all about, this bidirectional connection between particles, hair, and cloth. So those are some of the new features that are included in the Maya Entertainment Creation Suite 2013. We saw Maya, Motion Builder, Mudbox, lots of great technology. Thanks again to the XSense guys for helping us close off the show with a fun demo.
Thanks
John,
a lot, Daryl. So that was a look at the Entertainment Creation Suite with Maya. And again, you can see kind of the power you get with all these pipeline tools that are built into both Maya and Motion Builder to really create extremely high quality work, and in this particular case, high quality virtual production, which makes everything a lot easier in large things like films, video games. In fact, as we speak, Weta is using this exact same type of technology to do the Hobbit. This is what they used to do Tintin. It's really necessary with the complexity of the type of movies that people are building now with CG. You really need to have this virtual production.